What's up, guys? Welcome back to CF Corner. Welcome back to Create and Finish. Thank you for joining once again. Thank you for subscribing. Thank you for watching all our videos. Okay, really do appreciate. Okay, if you're just stumbling on this video, you're stumbled on the channel, or you're just watching for the first time, please do go ahead and subscribe and then turn on the notification bell such that you get notified with more videos that are coming up on this channel. Okay, today we'll be doing measurements. We're talking about measurements, how it relates to your space or whatever it is you have in your space that you want to measure. Okay, and this is a DIY video, a do-it-yourself video. After this video, you don't have to invite any experts or any specialist or anybody that has to do with probably doing your project or something to come and do measurement for you first. You can actually do your measurement first, and when they come, they can do theirs, and you actually can compare and see what the discrepancies are, if there are any. Do you understand? Besides, if you want to be very sure, you want to be very sure of what they are doing, you don't know if they're actually inflating or reducing the measurements in their favor. Okay, you want to really know what is going on. Okay, this video is for you. Now, a lot of people miss it when they start buying things into their spaces or start doing one thing or the other without taking measurements first. Okay, that is the biggest error you can start with in your space. It's a very big error. Okay, the very first thing anybody should do is to take accurate measurements, not just measurements, accurate measurements. You need to really understand what you are doing. Okay, right? Like if you're trying to bring in a piece of furniture into your space and you're not trying to check the position or that space, that corner where that furniture is going to be. Okay, you're not trying to measure it to check the dimensions. Okay, if it's going to size that of the furniture you're bringing in. Okay, you're doing yourself a huge disservice. Okay, and so the very first thing you need to do is take accurate measurements, and you cannot talk about measurement without mentioning things like the units of measurements. Okay, in Nigeria here we are more conversant with the square meters. Okay, I think in the US and the UK they use square feet a lot of times. Okay, now but before you talk about square meters, you need to understand what meters is, okay, or a meter is. Okay, we also work with inches, we also work with feet. Okay, a singular of it which is foot. Okay, so these three are majorly what we work here with most in Nigeria, but specifically, or would I say generally, people seem to be more comfortable with the meter. Okay, meter coming together is just an area of a space. Okay, you hear square meter, so 2 meters multiplied to give you a square. So when you're talking about an area, you're talking about a square combination of 1 or 2 to give you a square, whatever of that unit you're trying to do. It can be a square feet, can be it can be square inches, can be square meters, can be whatever. But when you're talking about volumes, then you're talking about the cubic meter. Okay, so we'll be talking more about the square meter today, but we need to understand what an inch is, a meter is, and a feet is. Now, simply put, all three are just units of length. You cannot go further to understand what measurement is all about without understanding how to use the measuring tape. Okay, so right here with me, I've got 2 types of measuring tape. This is usually called the pocket measuring tape. Okay, you have different sizes, you have different lengths of it. Okay, this is a 7.5 meter long measuring tape. Is also equivalent to 25 feet. Okay, 7.5, or you say 25 feet. Okay, there are bigger ones, there are smaller ones. Okay, you can easily put them in your pocket and move around. Okay, so this usually is most times used for interiors. Okay, maybe for just spaces close to maybe 10 meters, 20 meters. Okay, but when it goes beyond 30, 40, you're having 50, then it becomes something that be a little bit difficult for you to use, because you have to start breaking your measurements. Okay, so in that case, we use this. So this is majorly used for land. This is a 50-meter long measuring tape. Okay, so this is majorly used for land, 50 meters, and also calibrated in meters and feet. Okay, this is in inches, feet, and meters as well. Okay, so when you want to do something that goes beyond, that goes from 30 meters, 40 meters, in fact from 20, you could make use of this. Okay, if you are a professional and who's trying to probably take the measurement of the land, and you're going to decide with this, your client might actually think you don't know what you're doing, because you cannot take the measurement of a land with a 7.5-meter long measuring tape. Okay, it is advised that you go with the 50 meters or the 100 meters or 150, whatever that you have. Okay, so that will enable you to be able to understand what you are doing properly. You don't have to start cutting it somewhere and start over again, like when you are using this to cover a very long meters. Okay, so that's that for measuring tape. So we're going to go further to understand what the calibrations on a measuring tape like this talks about. Alright guys, so this is a diagram representation of what the measuring tape looks like. Before I proceed, I want to ask you to overlook the inaccuracy in some of the lines that are here. This is just something I drew up myself to get the message across. Okay, but it's pretty much same thing that you have in the live measuring tape. Okay, so the calibrations are just inaccurate, like are not really so accurate like that, but they are the same lines there. So right here I have the inches, I have the millimeters, I have the centimeters. Okay, you can see the labeling. You can see 1 inch and 2 inch labeled out. You can see millimeters. You can see the 61 millimeter and the 68 millimeter points labeled out. You can see the 8 and 9 centimeter points labeled out. Right, and right here, right up between 6 and 7 inches, you can see that I brought out a magnified view of the reading, the smaller divisions you have in between them. Okay, so it means that you can, after the main inches, you can have lower subdivisions again. You can have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. Okay, so you have 1/8 here. You expect that the next one should be 2/8, but then you're seeing 1/4 there. So what does it mean? 2/8 is also the same thing as 1/4. Okay, the common factor between 2/8 is 2. So when you divide through with 2, you have 1/4. The next one is 3/8. Next one is 1/2, which is the same thing as 4/8, 5/8. Okay, 6/8, which is the same thing as 3/4. Then you have 7/8. Now, there are also lower subdivisions there. You can have 1/16, the 16th division, right? So the 1/16, 2/16, 3/16, 4/16, 5/16, okay, like that. Okay, so I didn't bring that out here. So, but majorly our concern is with the centimeter and the millimeter and the meter. Okay, now right down you can see the numbers going from 1 to 2 to 3 to 4 to 10 to 20. Okay, I stopped at 20. And upper level you see the inches, 1 to 8 inches right there. Okay, so if we continue 9, 10, 11, 12, we're going to be getting 1 feet. Every 12 inches gives you a feet. Even in standard conversion factors you're seeing here, you're seeing 12 inches equals to 1 feet. Okay, but the key thing I want to drive home here is between every centimeter you have on every centimeter mark you have a 10 millimeter mark. It goes to tell you that 10 millimeter gives you 1 centimeter, which is also here in the conversion factor points. Okay, you have 2, 3, 4 like that. So before we get to 10, it means we must have gotten 100 millimeter. So it means to show that every 100 millimeter gives us a 10 centimeter. Okay, so and if we continue like that with the centimeters to 100, we are going to get a meter. So it is also what we have brought out here on the standard conversion factors. Now, going further, you now understand that every 100 centimeter gives you a meter. So if we continue after 100, we'll keep on getting like 110, 120, 130, 140, 150, 160, 170, 180, 190 to 200. Okay, when we get to 200, it gives us 2 meters. So that's the way it goes. So that's pretty much what we need to understand to be able to know how to measure. Once you can understand the readings on this diagram, it's self-explanatory, then you can understand how to go about your measurements. You can now understand that for every 10 centimeter you have, every 10 millimeter you have a centimeter, and for every 100 centimeter you have a meter. So it means on this tape rule I can stretch it out to 200 centimeters, and that will give me 2 meters. Since I know that this is 150, this is 180, this is 200, so I'm at the 200 mark. So it means when I get to 200, I've gotten to 2 meters. If I continue further to 10, to 20, and I get to 300, I've gotten to 300, I've gotten to 3 meters. Simply put, how do I do that? So to get a meter, what do you do? When you take your measurements here, just simply divide by 100, and it gives you the measurements in meters. Now, if I am measuring anything before 100, maybe I'm measuring from 50, 60, 70, or to 90, maybe I have 90 centimeters. So I want to take it to meters. What do? I just divide by 100, and it gives me 0.9 meters. Okay. After 100, then I have 1.1, 1.2, 1.3, like that, till I get to 2 meters. 2.1, 2.2, 2.3. But on your meter rule here, you might have 220. This is also the same as 2.2 when you divide by 100. So just understanding the conversion factor helps you further understand the readings right here. So it's pretty much simple, it's pretty much self-explanatory. If you want to understand the inches, all you need to do is just read on what you have, just read the tape. So after every 12 inches, you have 1 feet. Okay, like what we have here. After every 12 inches, you have a feet. This is 1 feet. Okay, this is a feet. So before 1 feet there, we have 11, 10, 11. So if we continue like that, we're going to have 2 feet, which is at the 24th mark. You can see 22, 23. Okay, and we have 2 feet. Continues like that. Another 12, we have 36. That's 3 feet. So the standard to get a feet is just dividing by 12. Okay, so 36 inches, how many feet is that? Divide by 12, you get 3 feet. Right, so that's pretty much what we need to understand about the measuring tape. So here is an example of some measurements. Again, before I proceed, please overlook the inaccuracy in the calibration here. This is just to break it down further. When you get the live or the proper measuring tape, it will help you to be able to take your readings properly. Okay, this is just to further explain or break it down. Now, quickly, example number 1, we can see 605 millimeters, 60.5 centimeters, and 0.605 meters. Okay, and you might be wondering, how did you come about 605? From our understanding that every 10 millimeter makes a centimeter, it means before we get to 60, we must have crossed 10, 20, 30, 40, 50. And between 10 to 20, or before we get to 10, we have 10 millimeters. Okay, it means using 10 to multiply 60 will give us 600. And the mark we have here is at the fifth point, that is between 60 and 1. You have that middle mark there, which is half, 0.5. Okay, so you have 6 601, 602, 603, 604, 605. Okay, so that's the reading in millimeters. So in centimeters, very simple. All you need to do is just to what? Just divide by 10, and then you get 60.5 centimeters. Then to meters, you just divide by 1000. Okay, so when coming back to millimeters, if the figures or the reading was in meters, all you need to do is just to multiply. So coming down to example number 2. Now what we have is just applying the same principle we applied in example 1. Okay, before you get to 160, it means you must have crossed up to about 100, right? Okay, and then we are at the 162 points. Okay, so doing your calculation there, you just see that the 1620, 1620 millimeters. Okay, so if you apply the method of what I just did in example 1, it will give you that of example 2. And again, when you divide by 10, you have the centimeter equivalent, and then when you divide by 1000, you have the meter figure there, right? So very simple and very fast to do. So like I always say, all you need to do is just to understand the readings of the measuring tape, then you can take any measurements you can think of. So I would advise that you go and probably get a simple measuring tape like I showed you earlier, and just try out some things on your own, and then you'll get better with it. Okay guys, in the example before us here now is a normal shaped room that is in a rectangular form. Okay, it's pretty much straightforward. To determine the size of the sitting room, measure the length of one part of the walls and then measure its adjacent wall and multiply. Okay, very simple. Take the length and then the width, and then you multiply them together to get the size of that space. Remember, you can use this to measure your ceiling, the size of your ceiling, the size of your floor. Okay, it's really pretty much different from measuring the wall. Okay, we'll see that in the next slide now. But this is how it goes. Measure the length, the width, then you multiply. From our understanding of how to take readings now, you can understand how to get something like 15 meters and 10 meters from your measuring tape, and just multiply them, and again it gives you the square meter of that space, right? Now the next one here is for measuring a wall space having a window. Okay, now this is a wall in a room, and then we want to measure the space, but then this wall is having a window frame on it. Okay, now to determine the size of the whole wall accommodating the window frame, just multiply its length by its width, like what we saw earlier. That gives you the area of the whole wall, including where the window frame is occupying. Okay, but to determine the free space on the wall, subtract the size of the window from that of the whole wall, which is equal to area of the space, which is 81 meters that we saw above, minus the length and the width of the window frame to give us 68.75 meters. Okay, it's pretty much the same thing with anything on the wall, for doors or for cabinets or for is it a wardrobe or just anything. Okay, so all you need to do is just to take the length and the width of that other thing on the wall there, and then you subtract it from the length and the width of the wall itself. That gives you the area of the space that you need to work on or do anything with. Yeah. Now this right here is an uneven room, or we say an uneven shaped room. Okay, now a lot of time people get confused on how to go about it. You see a room that has a shape like this, you don't know what to do. Okay, so what do you do? Pretty simple. To determine the size of an irregular space as this, all you need to do is to break the irregular shape into any possible rectangle, calculate the area of each of them, and then sum them up. Now from our knowledge of how to measure a space, or how to measure the length and width of a rectangle, from the previous example, you now understand that for you to get the total size of this irregular shape, you just need to break everything here into a possible rectangle. So you'll be able to guess the length and width of each rectangle, and after that you just sum everything together, and that gives you the total size of the space. Okay, so here is the divided portions, rectangular portions of this uneven space. We've been able to, this is just an example. This is not an accurate measurement that was taken. This is just to actually explain better and make you further understand what I'm saying. So the very first rectangle has its length as 5 and its width as 4. The second one, we're able to get the width, but for us to be able to get the length, we have to consider that of the first rectangle, which is 5, and its own smaller one that is here, which is 3. Okay, for the first one, we have an area of 5 by 4 to give us 20 square meters. Okay, that's 5 by 4 that we are seeing in the first rectangle. The second rectangle, we have an area of 8 times 5, which gives us 40 square meters. How did we come about 8 as a length? The 5 by the side of the first rectangle and the 3 down here that we are saying was summed up together to give us 8 meters, and then multiplied by the width, which is 5 meters, to give us 40. For the third rectangle, we have 11 by 4 to give us 44 meters square. Now the third rectangle pretty much applies the same principle that we saw in the second one. We look at the 8 by the side of the fourth rectangle as the length, because we've been able to break that length. Okay, we've been able to break that space into a perfect rectangle, and then we summed up the 8 length here plus the 3 up to get the total length of the third rectangle, because the total length of the third rectangle runs from up to down to the base where we have 4 meters as the width. Okay, so 8 plus 3 up gives us 11, multiplied by 4 to give us 44. Now for the last rectangle there, we have the fourth rectangle, which is simply 8 by 4, okay, to give us the square space of that fourth rectangle. Then after which everything is summed up to give us 136 square meters for that uneven space. Now this is the same principle you apply when measuring a land that has an uneven space, that is not a perfect rectangle. Okay, if you want to do that of a land, for instance, and you have a shape whereby it is not a perfect rectangle. In fact, there are two ways you can measure a land. The first way is to subtract the size of the house from the size of the whole land itself to get the space that you're trying to work on, right? Now, if that's not possible, the next thing you can do is to break the irregular shape that you are saying. If it's an irregular shape, to break it into perfect rectangles like we've seen here as well, and then take individual length and breadth of the broken parts, and then after which you sum them up to give you the total size of that uneven land. Okay, but if it's a straight rectangle, you can just remove that of the house from the whole land itself to give you the space that you are looking for. So pretty much easy. There is no rocket science in it. There is no big deal. So once you understand what the readings on the measuring tape talks about, then and you understand that you need to break every uneven space into any possible rectangle, then you're pretty much good to go. So that's that about that. Okay guys, so there you have it. So I believe with these simple explanations, with these few points, you should be able to understand how to take measurements of your space accurately. Okay, remember, you don't have to do so much. All you just need to understand is understanding the readings on the measuring tape. All you need to understand is know how to use the measuring tape. Okay, and then for uneven spaces that might get you confused, just break them into simple rectangles. Okay, for rooms, for lands, for anything. Okay, that way you'll be able to get the length and the breadth of such spaces, and then you take your measurements. Okay, having said that, don't forget to subscribe, don't forget to click the notification bell for more beautiful videos that will be coming up on this channel so that you can get notified when posted. So I'll see you some other time. Keep making your home the best of the best.